Hello aspirants, so we continue our journey with revising maps and entire geography for prelims 2026 and today we'll be covering Australia. So first of all, you need to understand the entire geography of Australia and along with that what tectonic plates were in the motion, why Australia looks the way it looks today. And the most basic thing is it has a stable land, and unfortunately it is in the wrong latitude and the wrong winds. We will see how westerlies affect an entire continent and make it into a desert land. Similarly, long latitude, we will be seeing how the Hadley cell is affecting Australia and turning it into completely desert. So that's why it is also called as the dry continent. You see, first, before going into any continent, we will delve deep into the tectonic margins. So this is the tectonic margin of Australia. Now look carefully what is happening here. There is a Pacific plate. It is pushing from here. Then there is an southeastern Indian ridge, but this is the Antarctic plate that is moving in from here. All in all, the land mass of Australia is stable. Nothing much is happening there. That means that whatever mountains and ridges Australia must have had at one point of time has completely eroded. So, this is one of the most technically stable continental blocks because everything is happening around Australia, in New Zealand, in over here in Southeast Asia, but nothing within Australia. So, it is extremely tectonically stable mass. That gives us that it has no active plate boundary, correct? So it has no young fold mountains. Yes, there are old mountains that have withered away over time, but there are no young fold mountains. And of course, no frequent earthquakes and volcanoes. So stable land, old surface, low relief, no forced uplift. So remember, Australia does not have any young fold mountains. Why? Because of this region, the tectonic area, everything is happening around but not within Australia. So let's move forward. Now, when we have an entire wind system that is taking place with the subtropical high and equatorial low, where do you think Australia will be? Pause the video here and try and locate Australia. So Australia will be somewhere around here because Tropic of Capricorn we know falls right middle of Australia. So whenever this question comes in the exam with any continental mass, try and look at where it will be falling. And this diagram you should memorize by heart. This should be at your fingertips. That where the northeast trade winds are blowing, where the southeast trade winds are blowing, what is happening with each of these cells. With repeated practice, you will become perfect. So this is where Australia will be. And that's how it is in the real life. So we have the trade winds. You see over here it is very organized, but that's not how it takes place in the real world. Real world is somewhere like this. Westerlies are going here and touching the continent, and northeast trade winds are moving like this. Equator, which you saw in the diagram, flows somewhere here. So where these trade winds are meeting with each other. That's why westerlies looks like this, but actually it is flowing in this direction. Westerlies going below. So even these winds are just touching Australia. But as we mentioned the tectonic boundaries, there is hardly any mountains to stop these winds and create rainfall. Things are getting together for Australia's sea. So we know winds are there, but there are no mountains to stop those winds. And winds are also just somehow touching Australia, but they're not getting blocked. They are free to go. And now we're looking at the Hadley cells. So I found this diagram from some thing which was going on. What I want you to focus is the falling Hadley cell. This is shown here, extremely hazy diagram, I understand. But Hadley cell is falling here. Damn smack in the middle of Australia. What is Hadley cell associated with? Hadley cell is associated with falling high pressure. So when there is high pressure on the ground, it will not rain, and that is what is happening here between 30 to 35 degrees north and south of the equator. Over here, it is south of the equator. See, this is the Hadley cell. It is falling damn smack in the middle of Australia. So it is a extremely high subtropical region. So what is happening here? This is how Hadley cell actually moves. Intertropical convergence zone. All of us know it is the equator, or however it shifts, goes towards Tropic of Cancer. So ITCZ also moves up, goes towards Tropic of Capricorn. So ITCZ also goes down. Now, when these winds go up and they fall in a subtropical high pressure zone, and that is your Hadley cell. This is the Hadley cell formation. So this subtropical high pressure zone is where actually Australia lies, hence no rains. Now the final part is oceanic currents. We have a cold oceanic current moving here. This is called the cold West Australian current, and we have a warm current flowing here, the East Australian current. So because of this warm current, and there is a range over here called the Great Dividing Range, there is some amount of rainfall taking place on the eastern part of Australia, but the western part of Australia remains dry. Number one, cold oceanic current. Number two, Hadley cell falling region. And number three, we saw how the trade winds and the westerlies are going there, but there is nothing to block. So winds also fail, creating in Australia a completely dry desert land. Now everything assemble, come together. First thing, tectonics sets the stage. Old surface, low relief, no forced uplift. So it is an old landmass. Second, latitude locks Australia under sinking air, Hadley cell. The biggest enemy of Australia and all of those regions lying in 30 to 35 degrees north and south of the equator is this sinking air of Hadley cell. Warming, no clouds. Then let's go here. Planetary winds. They try but they fail to help. Trade winds go somewhere from north of Australia, they move away. Westerlies touch just the southern fringes. And there is no mountain to block, like we have the Himalayas. Tall mountains, they don't. Finally, ocean currents. Ocean currents, they keep the West Australian current and keeps it very wet, very dry, but suppresses West Coast rain. So even if there is a rain kind of trying to happen over there, the cold oceanic current enforces further high pressure and does not allow rains to happen. Now, when we have understood what is going on with Australia, number one thing what we can show, what we can understand is interior deserts. It is full of deserts. Even the margins are semi-arid margins. Tropical north is there because of different regions which you don't have to get into, and narrow and humid east coast. It's because of the East Australian current. That is a warm current that is flowing over here, and the Great Dividing Range that is creating a rainfall. That's why we have a narrow humid east coast, but only this. Otherwise, what is Australia? Great Sandy Desert, Great Victorian Desert, then Simpson Desert, full of deserts. Now let's get into relief and drainage. So as we saw, it is a completely dry land. Not much rainfalls happening there because of different regions. So we have the Western Plateau, the Central Lowlands, and the Eastern Highlands. That's how we will be reading this. Drainage, just remember, there are short rivers, there is hardly any inland drainage. Most of the drainage of Many small streams come here, that is the Lake Eyre, and very few like Darling and Murray, only they reach over here. But now we are just focusing on how relief of Australia is divided. In relief, we have three: Western Plateau, Central Lowland, and Eastern Highland. Let's look at the Western Plateau first. Western Plateau, as explained, it's highly eroded, tectonically stable. Entire Australia is tectonically stable. This is highly eroded. Why is it highly eroded? You see, the biggest reason is that, first of all, it's extremely dry. High pressure, falling Hadley cell, and number two, cold oceanic current, the Western Australian current. What these two are doing is they are enforcing a huge amount of a high pressure and over the Western Australian plateau. Now, when there is no rain, it becomes extremely dry, and the winds over there keep on eroding those regions, thus resulting in a highly eroded, tectonically stable ancient shield region. We have the Great Victorian Desert here, we have the Sandy Desert, Gibson Desert, and the Nullarbor Plain. This is a limestone plateau. Remember this, the only reason I have put Nullarbor Plain is because UPSC tries to test out some weird names and weird things that are happening. Just remember, Nullarbor Plain is a limestone plateau. Central lowland. Now, this is another low-lying interior region. There are plateaus on the west, highlands in the east. In the middle, we have a lowland. In fact, this is so lowland that Lake Eyre over here is considered to be even below the sea level. So many of the drainage systems, many of the rivers drain here instead of going to the ocean. So you have the Lake Eyre basin here, you have the Murray-Darling basin here, and rivers are seasonal, including Murray-Darling. These are seasonal. Even when there are no rains and extremely dry conditions are there, Murray-Darling River has very narrow streams or extremely low water over there. Large inland areas have no outlet to the sea. And Eastern Highlands, this is the main mountain system of Australia. The only mountain system of Australia is the Great Dividing Range. Let me see whether there is a diagram for me to explain. Yes, just this, the Great Dividing Range. Only this. And second, if UPSC does not behave well with you, there is always Australian Alps. Just remember these two and you are good. This is what I was talking about, Lake Eyre. In this region, you will see many rivers coming in. Okay. So there will be many rivers coming in. And Murray and Darling are actually the river Murray. Darling is a tributary river Murray and it falls here. Somewhere here. This is the only thing that is going into the ocean, the only river system that is going into the ocean. The rest do not. Let's get back. Where were we? So we were in the Eastern Highlands. So this is the main dividing range. These are old fold mountains. Remember, Australia is an old stable landmass. No tectonic activity is taking place in Australia. All the tectonic activity is taking place around Australia, in New Zealand, in other parts of Oceania, in Indonesia, but not within Australia. And so, Great Dividing Range is not Himalayas. We have the Himalayas to create the great southwest monsoon system of India. Australians do not have that. It blocks some rain, but not a lot. In fact, snowfall is also rare in these regions. The highest peaks of Australia receive snowfall only during their winter months. I want you to guess what their winter months are. That will tell me and yourself how good your geography is. So, yes, we've discussed this. Now, Australia has poor rivers. As I said, no young mountains, no snow-fed system. First is Murray-Darling River system. So, Murray River originates in Australian Alps. That's why also this was important. Australian Alps. Murray River is originating from here. And it goes towards the Great Australian Bight. It's southern Australia. We will discuss the seas and coasts of the entire region of Oceania in the next lecture. So just remember, Murray exists because the Great Dividing Range exists, of course. Darling River is actually a tributary of the Murray River, and it joins semi-arid interior plains, joins the Murray River, and mouth is the Southern Ocean, more specifically the Great Australian Bight. Lake Eyre, it is an inland drainage basin. Rivers flow towards the center, not the sea. And there are some seasonal rivers over here. All you need to remember about Lake Eyre drainage is that it is below the sea level, number one. Number two, it has very high evaporation, and rivers flow towards Lake Eyre in Australia, not the Murray-Darling. Murray-Darling has its own basin. We are entering, now we are drifting from Australia towards Oceania. You see, there are island arcs. Why are there island arcs? In entire ocean collisions which we saw island arcs always form. This, as I had explained earlier, around all of these regions, ocean collision and ocean continent collisions are taking place. In the first lecture, I had explained that what happens in ocean collisions. Now, ocean collisions, what do we have? Ocean means a liquid is involved. Liquid is involved means there is volcanoes involved. That means there are trenches involved. Young fold mountains? No. Young fold mountains are in ocean continent collisions. This is present here. Trenches is also present here. We also have young fold mountains. That's why around Australia, yes, over here we also have island arcs, the most important thing, which creates Oceania as we know today. So there are these different islands that are taking place here and here. These are all island arcs because of this particular plate colliding with the Pacific plate on top. And that's how we say old Australia versus young New Zealand. Why? Again, tectonic plates. Old Australia is not seeing any action with regards to tectonic plates. Nothing is happening there. Very stable landmass. But New Zealand is in the middle of it. These two plates are in the middle of it completely. That's why there are young fold mountains in New Zealand, extremely tectonically active. Finally, if you have to wrap up Australia, you should just remember Australia is dry by design, not by chance. Unfortunately, there are deserts here. Why? You know why. Gibson, Great Victorian, etc. Lake Eyre is here. Central lowlands. And the Great Dividing Range is the only range that is worth mentioning in Australia. Extremely dry continent. Finally, in the next lecture, we will be entering into the depths of Oceania. We will be studying those island arcs, we will be studying New Zealand, and we will be studying the seas and straits, the Great Australian Bight. I also want to talk a bit about the Great Barrier Reef, the Coral Sea, and other such things which can be important for UPSC. But even if it is not important for UPSC, you will get a good amount of general knowledge that if UPSC sends a shocker, you will be able to manage it.